So hello everyone. This is the fourth question, and this is the maximum subarray problem. So we are being given an integer array nums, and we have to find the largest subarray sum. Subarrays are continuous, as you will be knowing. They cannot be discontinuous. Suppose 2 1 minus 2 1 minus 3 4 is one subarray. Minus 2 1 4. Skipping the minus 3 is not a subarray. Okay. Now let me for to explain you about this particular problem, let me take a part of this particular array. For this part, minus 2 1 minus 3 4, let us assume that this is the array that we are being given. Now can you say what is the maximum subarray sum? Now consider all the subarrays. Okay, minus 2 1 minus 3 is one subarray. All the single elements are one can be considered as a subarray. Okay, all the single elements. These are 4 subarrays. That means these are subarrays with only one element. Okay, minus 2 1 is one subarray. 1 comma minus 3 is one subarray. Minus 3 comma 4 is one subarray. Minus 2 1 minus 3 4, the whole array is one subarray. And 1 minus 3 4 is one subarray. Is there any other subarray? No, there are only these 10 arrays, I guess. 4 into 5 by 2. So number of subarrays is always, I guess, n into n plus 1 by 2. So these are the subarrays. If you see the sum, minus 2, sorry, minus 2 1 minus 3. So here if we consider the individual elements, the largest sum will be 4. Minus 2 1 3, what is the sum? Minus 4, it will be minus 4. Then it will be minus 1, it will be minus 2, it will be 1, it will be it will be 0, and it will be 4 5, it will be 2. So the largest sum here it is 4. So this is the only a single element 4. This is the largest sum subarray, maximum sum subarray. So this is actually a divide and conquer problem which can be solved using recursion. Now so let me consider a sub problem. Okay, so if max of subarray ending at index j, what is the maximum subarray sum ending at index j? Can we write that if the maximum subarray sum ending at index j minus 1, if it is positive, then we will be, if we add this particular subarray to our current element, now of course it will be optimized. Okay, the global optimum will increase. That means suppose this is the maximum sum array, take it as 5, and another maximum subarray, this is minus 2. Okay, and this is the current element 4 4. Now if this element is positive, then should we add this particular element to this? Of course, because it will increase it. Okay, but if it is negative, should we add minus 2 to this particular element? No, right? Because it will decrease this overall optimum. Okay, the overall optimum answer, it will decrease. Instead we can use single 4, because among this minus 2 and 4, what is the largest subarray? It will be 4, because If you consider minus 2 and 4, the sum will be 2 only. But if you consider single 4 only, then the sum will be 4, which is greater. Okay, so that's why adding this negative subarrays doesn't make any sense. Okay, so this is the basic crux of this solution. So if it is the previous the maximum subarray sum ending at previous index is greater than 0, then we'll be adding it. Okay, maximum subarray array j minus 1 to this current element. If it is less than equal to 0, then what have happened? We don't need to add this element, because if it is negative or 0, then it won't be of any value to us. Okay, instead, if it is negative, it will decrease this current element. So we'll be taking only this single element. That means if the previous, this is the current element, if the previous the maximum subarray up to ending up to this index is negative, then it is better to start from this index a new subarray. Okay, because if we add, whether this is minus 2, whether this is plus 2, whether this is positive or negative, it doesn't matter. If we add negative to it, the total value will tend to decrease, right? So there is no point in adding this negative or 0 value. So this is the equation. That means the maximum subarray sum ending at index j, we have to see if the maximum subarray sum ending at index j minus 1 is greater than 0. If it is greater than 0, then we'll be adding this to the current element, that means a of j. Else we will be considering a new subarray from a of j. Okay, so that is the question. So let us come to the code. Now let me create a separate function for it. And in the index, let this be the answer. Okay, we will initialize it to int minimum, and there is a base case. Okay, if n equal to 0, that means if we have reached the last index, we'll be storing first storing the answer and we'll simply return this value. Okay, else this will be not the global answer, this will be a current answer. Let me give it a variable name of current answer. Now current answer, if the max of let us initialize it to max of subarray for the previous up to ending at the previous index. Okay, if it is greater than 0, then we'll add it to the current element. Else we'll start a new subarray from this current index. Now finally you return this current answer, but first of all, before returning, you have to save it to the global global answer. Okay, now we'll call this function using max of s array n minus 1, and at plus what we will be needing to return is the global answer. Okay, I think this should work. Mm, sorry, we have to continue. 47. Okay, we have not declared n. Okay, it will be array dot size. I think this should work fine now. Okay, yes, it is working. Let us submit. Yes, this is working. Now, there is a follow-up question. It is given that we have to figure out the O of n solution. Now, for O of n solution, you have O of n solution. You have to memorize it and then follow the dynamic programming approach, which I will be explaining. This is a recursive approach, and it's basically a divide and conquer algorithm, because you are dividing that particular problem into sub problem. That means you are dividing the whole problem. That means the maximum subarray of sum of this particular array, which ending at index n minus 1, we are dividing it into, say, uh, further smaller problems, and then when we reach the index 0, we are creating this as a base case, and we are returning this answer. So I'll follow up with the dynamic programming approach in the upcoming video, because this video, I think, is already now about 10 minutes long, so I won't be making it more longer. So thank you, everyone. Let's meet in the upcoming videos.